Hi, folks. We are all super excited to be chatting with you today about not only how to deploy automation, but how to design a deployment and an automation system that is a genuinely worthwhile investment for you and your site. I'm Andrea Meister. I've been here at Vector Robotics for the past 3 years and more broadly in the automation world for quite a while now. For my first year or so at Vecna, I exclusively ran deployments. So I always have that bent of what is going to actually work for the people with their boots on the ground in a warehouse or a manufacturing facility, and how do we drive automation there?
And I'm Fred Hager. I come from an engineering and product development background. I'm working specifically on our pivotal workflow orchestration software these days. It's great to be here.
So let's jump right in. I imagine most of you are here because you know you want to augment your operations with automation. If that's not why you're here, maybe you stepped into the wrong Zoom room. But to give a quick overview, why automate? You get more flexibility in your day-to-day operations in terms of what throughput and what hours you work. You can see success in growing your operations without growing your operational expenditures, and increased workplace safety. So when we talk about when to automate and how that's going to look, I want to stress here that the goal isn't a lights out operation. It's to augment an operation with operation. The kinds of skills and smarts that people bring to the process are not likely to go away anytime soon. So things that require a judgment call, like, is this pallet stable enough to stack another pallet on top of it? Or my warehouse is at 98% capacity and I need to figure out where I'm going to put product that's still coming into the doors, are usually best left to leave a person in the loop. But AMRs are great for that repetitive, boring, high transit time work. And we see a lot of gains there, taking away that very repetitive work. Last of all, I always like to encourage people to automate a site before the volume becomes a challenge, not once your team is already spread thin and pulling heroics to handle it. As an ops guy, you're never going to want to, take a risk, try something new when you already feel like you're barely keeping your head above water. And we're going to get into way more depth on all of that today, structuring our conversation around a few key considerations for designing a successful AMR deployment. In essence, we're going to talk about choosing the right tool for the right job to work with and for the people who matter the most. Obviously, it's also critical to have that product traceability and be following the lean methodology by integrating with the WMS. And to set up for both initial success and for continuous improvement. So let's talk about using the right tool. When a new application for a customer comes across my desk, the first thing I'm going to do is break down what's the automation ask. So I'm going to think about what steps need to take place for the work to happen and what capabilities an agent needs to have to do that work. And when I say agent, I mean a person, a reach truck driver, a robotic tugger, a robotic forklift. All of those sort of agents can do different kinds of work. So let's take an application I see all the time. A warehouse wants to automate their inbound receiving process. In that workflow, a trailer arrives at the dock door and needs to be unloaded into a staging lane. That staging lane needs to be QC checked. Pallets need to be moved from that staging lane into storage. They need to be racked, and finally, all of this needs to be tracked through WMS. The first two parts of that workflow are usually best left to people who can maneuver a vehicle well in a tight space like a trailer and do that sort of smart work, like checking that all of the product coming out of the truck is complete and undamaged. From there, the robots can really do the rest of it. Transport, racking, tracking, and communicating with the WMS.
Just jump in here for a second. One mistake that we see a lot of early adopters make is that they think that unless they can cover the entire workflow with automation, they don't it doesn't make sense, so they don't want to get into it. But really, more often than not, there's a lot of worth in automating parts of the workflow, especially the parts of the workflow that make a lot of sense for the robot, while still leaving other parts with humans.
Yeah, that's a great point. I remember about a year ago, one of my last on-site visits before COVID hit, I was talking to a process engineer who had tested out basically every type of robotic automation on the market. And he had a very realistic outlook on what he was going to get out of that. He knew he wasn't going to get sort of that silver bullet that was going to just, automate his entire warehouse in one fell swoop. He actually compared it to more like panning for gold, where the wins were sort of, parts of a process. What could he get better efficiency on? What could be improved? And sort of was looking for those incremental improvements. So in that line of thinking, I worked to set up a workflow that people are doing the things that they can quickly and easily do, and robots are doing the things that they can efficiently do. And to put a really fine point on what I mean by what AMRs do well, it's that product transportation portion. In most of the applications, I see MHE drivers on any platform, so like a double jack, a forklift, a reach vehicle, spend about 75% of their working time driving from one point to another. And that's sort of that portion that AMRs can do really efficiently to sort of free up those people to do the smarter value-added work. I've talked a little bit about manual versus autonomous work and how to divide that up, but I also want to briefly touch on, there are a whole bunch of different robotic platforms that can work together or be deployed to similar use cases. These are just a handful that we offer that are sort of different tools in the toolkit to do different things or work together on similar applications. So an example of that, again, let's use that example of receiving lane transport to storage. If you want to mimic sort of exactly the way a manual operation works, you could use a pallet truck that interfaces with the same staging lane setup already in place. The unloader sets out all the product into the lane, the checker signs off on the whole thing, and gives that work to our pallet trucks, which are going to work asynchronously, so nobody's watching them, nobody's helping them do their task. From the manual operation, they'll autonomously detect what's in the lane, scan the barcode, auto-speed the pallet, and transport it to the right destination. A less conventional option that we've been seeing a lot of early success with is, and this is a little bit unconventional, you don't usually see tuggers in a warehouse environment, but they can do the same work. You tend to see success on these when a trailer is, for example, being unloaded continuously, so the tuggers can work in this synchronous process, being loaded, then doing that long haul transit, and sort of meeting a manual driver at every step to get loaded, unloaded. The biggest advantage here is capacity, and that's one of the perks of, or the sort of unique aspects of this agent. A tugger can carry 4 to even 10 times as many pallets as a single or a double pallet moving vehicle. So you see those huge jumps in throughput. So we've talked about finding the right tool that is not usually just one tool, but a mix of robots, different robotic agents, and people. The next section is finding sort of the right job and how you can validate that even before a robot sets its wheels onto the site. I've specifically talked about a particular warehousing use case right now, but I want to highlight that there are a whole bunch of different viable AMR applications, both in that sort of warehousing space as well as outside of huge distribution centers. I'm thinking of a variety of non-value added transport or opportunistic moves, the types of dynamic milk runs you'd see for delivery to line side in manufacturing applications, transportation of those non-conveyable packages, think kayaks, think those mattresses that get shipped to you in parcel sortation. And then of course those fork truck specific applications, interfacing with racks, interfacing with conveyors, palletizers, other equipment.
Yeah, for each application, in each industry, these workflows have their own names, their own quirks, their own aspects to them. But really, if you boil them down to what the automation component of the solution needs to do, it really comes down to look very, very similar across all of these examples when it comes back to kind of the back end of our system.
Yeah, and that's something that's very cool in that we can, you know, work across a variety of workflows that all sort of look the same to a robotic agent. I also wanted to talk a bit about if we're testing, you know, an application that we haven't seen before, or are deploying a large fleet. A great tool to use here is a robotic simulation. This is almost like a virtual deployment. We set up a model of your site where the work will come in and when. Our simulation tools allow us to visualize and get some sort of numbers on how it will work. A simulation is great for determining an exact fleet size for a large or complex operation. You know, if you have 50 robots, but you have to know you need exactly 50, not 49. And we can also test out different scenarios at a lower cost than you could get even by just deploying a single unit. Another big advantage here is at a greenfield site, we can sort of aid in that design where you don't necessarily have all the numbers yet. You can sort of run different situations.
Yeah, and a key about these simulations is it lets you play what if games without having to commit to real robots. But at the same time, it gives you a lot of information that will not come out of a spreadsheet or a similar simple model. The main thing being is that these agents, even though they're virtual, they're still occupying virtual space. That means they're getting stuck, they're queuing up behind other agents. They have to wait their turn and things like that. So bottlenecks and other issues will just pop off the screen that become very, very obvious to see if you watch one of these. So what I like to do when I work with a simulation project like this is kind of twofold. One is I want to carefully watch individual runs, like what's here, to kind of get a sense of how does the fleet feel in the site. Where do robots bunch up? Where are they spreading out? Are they causing congestion? And that very quickly points to areas that I need to look at more carefully, or need to work with a customer ahead of time how to address this. And the second part is to run a whole number of randomized experiments where I just tweak and very small things to get a sense of how robust is that solution to changes, to disturbances and whatnot, and how can I kind of preempt what is going to happen before robots ever hit the ground, so I can work internally and with our customers to make sure the solution is ready for that when the robots actually hit the ground. So we're really talking about automation, specifically about how to successfully deploy those solutions. Along with everything else, everything that Andreas talked about so far, the key element to a successful solution is really how well it works with the people that are so part of the process. I think that's come up a number of times, and I'll mention it a few more times before through the rest of this presentation. This all may sound a little bit strange coming from a roboticist, but we've really found this to be true time and time again. Our robots augment the work that your staff are doing on the floor. As Andrea said, robots are really good for many things, but there are always, and there always will be, situations where people are the better choice, and that makes them the right choice for those parts of workflows. The nice thing is that where people and robots, the strength of people and robots are very nicely complementary. The robots will happily perform tedious, long, maybe even boring tasks without complaining, and that frees up people to do all the value-added work that we've mentioned before, things that require their skill and intuition. But for all of this to work well, the automation has to seamlessly fit into and be intuitive to the people using it. If a person has to wait for a robot to do their next task, or interrupt whatever they're doing at the moment just to deal with a robot right then and there, they will likely not be very happy with that solution, and it will not work well in the bigger picture. But what does that mean in practical terms? For one, in order to work with people, robots have to get close to them. That sets a very high bar in terms of the safety requirements that the solution needs to meet. From our end, we always try to decouple the task assignment from the robots themselves whenever possible. Think about this as assigning work to the system or to the fleet of robots rather than to specific robots. And with this interface to people, the robots need to be able to, and in some sense, almost need to be comfortable with working with what we call human precision. People place pallets in the right spots most of the time, but they will be slightly misaligned. They may stick out a little bit more one day or a bit further back in. And some of those protrusions may go into the space that the robots expect to or would like to use. The robots need to be able to deal with that and handle that.
Yeah, and just to jump onto something that Fred said there, the most important commodity you have is your employees' time. So the robots need to be able to figure out a lot of problems by themselves.
Yeah, that's a great point. The robots are great tools, but they are not the eventual key to success. All the points we just mentioned really help the automation and the overall system to work well with and in the end for the people that are so key to the workflows that need to be addressed. In the end, any solution will only work as well as it's seen and accepted as a positive change at all levels of your organization, from the site management that may be pushing for an automation, but also all the way down to the staff on the floor who will work with the units on a daily basis. With every project, we engage with the customer early on and to get everyone on board and to address any issues that we've seen in other sites and so forth, anything that can aid adoption right from the start. A couple things we've consistently found to work really well. One, find a project champion at the site, somebody who is excited about technology, about this technology in particular, but any technology in general is often a good fit there, who can transfer their excitement both to coworkers at the site and ultimately even across your organization as solutions or similar applications roll out. The second part is make some members of your team very explicit robot experts. Give them the tools and power to kind of know everything about the robots, be able to help them, be able to take charge and be in charge of them. And everybody thinks robots are cool, so this is often a very coveted position.
Yeah, I feel like the picture that really says 1,000 words here is, I think this is the one up on this screen that like has some of like our robot experts, and they made like little like robot wrangler t-shirts, and to me this is my favorite picture we've ever taken of our robots, and it's just the picture of why empowering your site champions gets you that fast adoption.
Yeah, that's exactly right. And then finally, give your robots names. We've had superheroes, movie characters, cartoon robots. One in this picture, shown in this picture here on the left is Hulk. We get that a lot with our green robots, but anything that puts a personality to the robots is just a huge boost to how they're perceived. Teams on site will usually run naming contests, maybe even win a prize, and but what this really does is that before too long, the robots have a personality, and people will ask, "Oh, have you seen so and so come by? Well, what's up with where is it? Where is that robot today?" And that's really fun to see. So we talked a lot about humans, and there's kind of a recurring theme throughout this, and how they're so key of a successful automation solution. But that really doesn't mean that they should have to tell the system everything it needs to do to be productive, and even quite the opposite. The more information our system has about the workflows that it's a part of, the better it can support and the work that happens all around it, before the automation takes over and the activities that happen after the robot's done with its part. It's very much in line with what we talked about earlier. Automation is successful if it makes sure that people on either end of it can work productively. That may mean that freight gets picked up from a dock quickly enough so that it doesn't cause backlogs for others who unload trucks. Or it may mean delivering packages to a transfer point at a rate that matches the handler's work rate there, so that they're neither slammed and overloaded nor idle. And information is really the key to make the automation smarter. One benefit we have is that our system has a certain amount of global information, goes beyond the visible horizon, things that people doing similar activities today just may not have and can't act on. But at the same time, it doesn't mean that every solution must be fully integrated right from the start. With IT systems and other things. Many of you have probably gone through this type of an integration process, and it always seems to come with its own set of surprises and challenges. For most solutions we start with as little integration as we can to make the robots useful without being tedious to the user. There's a balance here. That may mean user interfaces on tablet devices, simple call buttons, and things like that. And for some solutions, that's really all that's needed, and they will never need any more integration, and that's perfectly fine. Other solutions may over time add integrations to WMS or to other systems to kind of tie the automation more and more into the overall workflow, into the process, and into the bigger picture. Ramping up the level of integration incrementally really helps everyone involved. It gets the solution going more quickly in most cases, and it allows both the site to get used to the automation and combination of our customers and us to really understand what the right level of integration should be, that is not just integration for sake of integration, but that actually helps the overall solution be more productive. So after a solution is deployed, you want to know that it is working and how well it's working. Well, it's pretty easy to measure how fast the robot's moving, how long it takes it to pick up a pallet, and other kind of agent-based metrics like that. The challenge is that these don't tell the whole story. What the automation really needs to do is to augment your team and to collectively be as productive as possible. And to achieve that, the key to that is really that robots need to work autonomously or without needing help from anyone on site who, again, needs to interrupt what they're doing or even go and find the robots. Robots need to kind of be self-sufficient almost all of the time. But we all know that robots will run into issues and where they might need help before they can continue autonomously. They're usually very good at knowing that something is wrong, but equally they're very bad at knowing why. I guess if they knew why, then they wouldn't be stuck in the first place. With our network operations center, the robots can call for help and when they need it, and then a person can check in, can see what's going on, can provide a critical nudge, kind of come in, nudge, and go on to other things. And to the site, they may get a notification. They may see that the robot is being assisted, but really from a from a operationally, that robot is still moving on its own without needing local assistance. In fact, oftentimes our team can even address issues and resolve problems before the site even knows that something either was wrong or was going to be wrong. All the data that's collected by our system, or by any system really, about individual vehicle operations, about the overall workflow, and about problems that are encountered and then also resolved by a support team, feeds a continuous cycle of learning and adaptation. And really, that's what makes an AMR solution really adaptable and future-proof to changes to process, to volume, to demand, and all those kinds of disturbances. So we talked about how to think about automation solutions as a combination of the right tool and the right application, and how ultimately human productivity is the key consideration. That's what the automation needs to support. Information integrations can help, but as we talked about, they're in no way mandatory, and they're certainly not the thing that needs to happen first before you can even get started. And finally, a successful deployment is really just the first step in a continuous loop of data-driven improvements to and adaptations of the system, of the solution, of the automation into your processes and workflows. Thanks for joining us today. Please check us out and feel free to contact us with any questions or follow-up. I hope you enjoyed the presentation and you learned something new today.